This is the Chapter 2 review worksheet. We're going to start with number 1, sounds like. Okay, number 1 says find the number of tickets that need to be sold to maximize the profit. So when you hear the word maximize in a quadratic equation, what are you looking for? The vertex. So what is the shortcut to find the x value of the vertex? What is the shortcut to find the x value of the vertex? This looks familiar. Opposite of b over 2a. That's familiar? In algebra 2? It's the equation for the axis of symmetry. So here is our b value. Here is our a value. And we want to find that vertex x value. So opposite of b over 2a. Now we reduce it. Negative 800 divided by negative 32. What does that reduce to? 2.75? Okay. So that is your x value. When, in this case, if we change the variable t, t equals 2.75. Find the number of tickets that you need to be sold to maximize the profit. So if we think about this parabola, it opens down because it's a leading coefficient of a negative. This is 2.75 comma question mark. Do we care? Find the number of tickets is what we found. So the maximum tickets is 2.75.
Should be 25.
25?
Yeah.
Negative 800 divided by negative 32 is 25? Is that not? Is it 25? Should, okay.
Yeah.
Oh, I didn't know you
2.7.
I was like, that's what I was kind of like, that's not a lot of tickets to maximize.
Yeah. That's
25, yeah. I'm like,
kind
huh?
of, not
I'm
a
like
lot of profit there.
2.75 tickets. No, they're not selling a lot, right?
Woo!
Woo! So 25 tickets.
I wouldn't want to try and go see that show if they're only selling
No,
2 3/4 tickets.
definitely. All right. What other questions do you have for me? Yes.
17C.
17C. Grab each and label all the pertinent information. So let's look at the degree first. What is the degree of this function? Is 4, and its leading coefficient is positive. So what would be the end behavior? Rise and rise. And the shape is going to be what? Of a 4th degree polynomial. W or an M. In this case, which one will it be? A W. So we know the end of our picture should be a W. So then we have to go out and find.
That is a perfect circle.
That's a perfect circle? Oh, thank you.
Yeah.
Yes, I've been practicing a lot. Okay. We need to find the zeros of the function to find the x-intercepts. So let's start with the zeros. So we set the function equal to 0 and we solve for x. How do you factor that? Can you split it up as an x squared and an x squared split up? And then are there factors of 12 that add to negative 1? Factors of 12. 4 and what?
3 and negative 4.
3 and negative 4?
That's
Negative 4.
I think there's an error. It should be a negative 12. Just can't factor that. If I remember right, this should be a negative.
So which makes it
So it makes it factorable. So then you could do a negative 4 and a positive 3. So just go ahead and change that on your worksheet. Should be a negative 12. So then you can factor it as negative 4 and positive 3. Then you would set those factors equal to 0 and solve for x. You can solve by undoing, or you can continue factoring this one. X squared equals 4, so then x equals plus or minus square root of 4, which is plus or minus 2. And then over here, we get x squared equals negative 3. And then we would square root that one. And then what pops up as a radical? A negative. So this would be x equals plus or minus I squared sub 3. These are your zeros, but this is not x-intercepts because they're complex zeros. These will be your x-intercepts. So you'd have an x-intercept at 2, 0, and then at negative 2, 0. So then you could go out and graph those. 2, 0, negative 2, 0, and it said that the leading coefficient was positive, so I know those have to go up then as my end behavior. And then what I would probably do is check and see if there's symmetry, or plug in a couple more values in there and see what would happen between negative 2 and 2. So you'd say f of 0 and figure out what that would be. So your original function was x to the 4th minus x squared minus 12, and plug in 0 in. So you get 0 to the 4th minus 0 squared minus 12, which is negative 12.
How does it
Hmm?
give you about that?
Hmm?
It's gonna be way down here.
That's fine.
No, how?
Let's say down here. So then maybe it kind of might go like this. We don't know for sure. Then you just find a couple more points in here, maybe negative 1. Does that help guide you then, Karen?
Yeah.
Okay, so then we'll just say this is negative 12 here. And then just try a couple more. Next question. What else do you want to go over?
Can you do one of the 16s?
Yep, which one on the 16th?
C.
16C. Okay, find the domain, vertical asymptote, and horizontal asymptote. So this is a rational function. So to find the domain, we look at the denominator, and we look at what restrictions might be with the denominator. So 2x minus 18 cannot equal 0. So we would solve that for x. Add 18 to both sides, and then divide by 2. So x cannot be 9. So be all reals except x can't be 9. Then the vertical asymptote would occur where? At 9. So there's a vertical asymptote at x equals 9. Then we look at the horizontal or slant next. The degree of the numerator is 1. The degree of the denominator is 1. So what do we do when the degrees are the same? Divide by their leading coefficients. So we're going to divide by -2 or -6 over 2. So the horizontal asymptote will be at y equals -6 over 2. And then we reduce that down. It doesn't ask for us to graph 16 sets, so those are the three things it asks us to find.